Hello, and welcome to the Univac exhibit at the System Source Computer Museum. System Source Computer Museum is in Hunt Valley, Maryland. We're 4 miles outside the Baltimore Beltway, and we're looking forward to hosting all of you to see the whole museum and not just a single exhibit as soon as the COVID-19 crisis is over. The Univac 490 is the largest single CPU that we have in the collection. Here we're looking at a 12-foot long chassis. It is 6 foot 6 inches high and approximately 3 feet deep. So it's a big boy, and that of course is just the CPU. The entire system took up full rooms, and we're extremely lucky that Sperry hired photographers to take pictures of all the Univac 490 setups, and they are on deposit at the Hagley Library in Delaware. So the Univac that we have is at the very left-hand side of this picture. There's a console and a number of tape drives in this picture. Here's another picture with what looks like a line printer and possibly a card reader in it. Yet another room-size setup. In this picture, we see the Univac set up with its original mass storage, which would have been memory drums. So memory drums are large spinning cylinders coated with a magnetic material, very much like a disk drive, except that on a hard drive now you have moving read-write heads. The drums had fixed read-write heads, one for each track, and they're over there in the left-hand portion of the picture. In 1963, when this unit was developed, there were no hard drives, but later that year, Sperry did introduce some hard drives, and that's what it looked like. The Univac 490 is also the slowest completely electronic CPU that we have in the collection. When we got the Univac, the iPhone 4 was new a few years ago, and I did a little bit of benchmarking just based on the statistics, based on floating point multiplications and divisions. The iPhone 4 is on the order of 110 times faster than our Univac 490. In a strange coincidence, if we lined up iPhone 4s and stacked them, 110,000 iPhones would fit inside the chassis of the CPU of our Univac 490. So it's not the fastest thing in the world. It's also the most expensive CPU in inflation-adjusted dollars that we have. So the CPU alone, each one was sold for $2 million. A large number of organizations bought them. One went to the Bowery Savings Bank. We'll see a picture of that. Several went to the airlines, and 6 of them. You may have noticed that the signs on the Univac 490 say real-time system. So what we mean by that is most of the computer systems in the 1960s and even through the 70s when many of us got our start, the computers were batch-oriented. What that means is that we sat down at a key punch machine, we key punched our program, we walked over to an operator with a deck of cards, the operator read the cards in, we waited. In my experience, it was typically about a half an hour, and then we would get a printout on green and white barred paper. It was done that way because computers were just way too expensive to sit there waiting for Bob to type a character into an online editor. But batch-oriented systems don't work too well for real-time data. So examples of real-time data that we'll talk about are things like telemetry, getting data from flying spacecraft in real time. Another application would be for airline reservation system. Again, real-time applications. We have to keep that database right up to date. So our Univac 490 was installed at Goddard Space Flight Center. You can see it a little bit here in the very back. Over on the right-hand side of the picture here, what you're going to see is a map of the world and strings that represent where NASA had tracking stations. So the computer's obviously way too large to fit inside the Gemini or Apollo spacecraft. Instead, the spacecraft had radios in them and telemetry data, what the astronaut's heart rate was, what their blood pressure was, the performance of the aircraft itself was all beamed down to Earth in a narrow beam. In order to capture that data, NASA had ground tracking stations. So here's a picture of the antenna that tracked the spacecraft that was at Goddard Space Flight Center in 1968. But because it's moving all the way around the Earth, one of these isn't going to do the job. We need a dozen of them all around the world. So here's a picture of another NASA setup in Madrid, Spain. And in some cases, there's no land where you need a tracking station. So the tracking station was on a Navy ship. Each Navy ship had a Univac 1218, also known as the Univac CP855 UYK. It's an 18-bit computer that gathered the data from the satellite, sent it over a radio modem, and the radio modem's connected to Goddard Space Flight Center. Back here on our Univac, up in the mirror, you can see the connectors up at the top. That's where the data feeds came into the computer. Closer look at that. This is again on the very top of the computer, and I'm embarrassed to notice right now that we have one of our infamous stink bugs stuck in connector J063. So just here's an article explaining how it worked. Just in the first sentence here, I find it interesting. Highly reliable Univac 1218 computers operated for a total of 910 hours during the historic Gemini 4 space mission without a single failure. So it's only 910 hours. It doesn't feel very long. But the mean time between failure quoted for both our Univac 1218 and the Univac 490 was only 1,000 hours. So there were 2 Univac 490s at Goddard Space Flight Center, and there were more at Mission Control for redundancy. Another use of the Univac 490 was in the first, what they called PNR, Passenger Name Record System. So what's going on here is before the Univac 490, when you made an airline reservation, you spoke to someone, that person got out a notebook, found that day's flight, wrote your name in, and you had a reservation. If you changed your reservation, somebody got that book and got some white out and crossed it out. With Eastern Airlines and British Air cooperated to build an operating system for the Univac 490, and they were able to have 1,000 terminals like this going over modems and building really a forerunner of the modern reservation systems. I'm particularly excited about the Univac 490 because it was the first real computer that I ever personally saw. So the American Library Association brought a Univac 490 to the New York World's Fair that was in 1964 and 1965, and visitors like me could look in and actually see a computer, and then we could walk over to a terminal and type in any subject, and as long as there was an entry on that subject in the Encyclopedia Britannica, we would get a printout that we could take home. I do have an example or two in the museum. So it's really sort of like the internet today, although in this case the only source was Encyclopedia Britannica. So that was probably not the most popular exhibit at the New York World's Fair, but it caught my eye. So now let's take a look at how the Univac is built. So our Univac is built with only about 18,000 transistors. They're discrete transistors. Integrated circuits would be a number of years in the future. So there are approximately 1,000 of these boards. Here's a closer look at one. Each board has a handful of test points. Reliability was not yet there, so you can test each board through these test points. And corresponding to each board type, we're lucky enough to have a complete set of schematics. We can see how that is put together. So I'm not much of an electrical engineer, but these are simple enough circuits that even I have some chance of understanding how a line driver works or how a flip-flop works or all the various types of cards that are in the system. So there's some close-ups of it. The cards are in the front of the computer. In the back, we have this crazy rat's nest of wires that connect each of the cards together. And I would love somebody's explanation as to why they used so many white wires. Clearly they had colored wires because we have some orange wires and some red wires and some red-white wires and some yellow wires. But there are thousands of white point-to-point connections on the back plane of the Univac 490. So our Univac 490 has core memory. Here's a close-up of some cores. We have 90K words of memory. 30K words of memory. The word length on this is 30 bits, so today we would call this 96K of memory. That means there's about 900, for 96K, that would be 96,000 bytes. Each byte would have 8 bits plus 2 parity or error correcting bits made out of these little magnetic cores. So these are ferrite cores, and by putting a voltage on the X and Y, we can flip the magnetic field. And then we have a diagonal sense card so that we can read any individual core. These cores are pretty tiny. So a core plane looks like this, and there's a whole stack of these core planes. And on top of each core plane are the diode matrix for deciding which bit or byte we're trying to get to at a time. So there's stacks of these cores here and here and here and here. There's about 10 deep here in the middle on the bottom. And then there's another set of them on the other side of this door. This door weighs about 280 pounds for our 96 kilobytes of memory. The door is open. These gentlemen from the Bowery Savings Bank are admiring their new Univac. So here at System Source, we're trying to emulate the former and hopefully future Living Computer Museum. We do have many, many, many working exhibits. We would love to turn on the Univac, but our Univac has not been turned on since 1969. So today's the 12th of July. James Mahoney was up from helping build a tester. So Dwayne Craps, who's been a member of the Vintage Computer Group up in New Jersey, had built and had worked with an audio tester. He was nice enough to send us the schematics for one. James bought one. So with this, we can take each card out and test that each card behaves the way we expect it to, one at a time. The next step that we're beginning to think about is how do we turn this on? We have a 280 volt power supply. It has 15 positive, 15 negative, -3 volts. It also has some higher voltages in it. I'm frankly afraid to plug it in with the giant capacitors. I'm leaning towards just buying a modern power supply and cleaning up the old one. But I would love anybody's advice in where we go to turn this back on for the first time in 1970. So it's the first time in about 51 years. So the images came from a bunch of different sources. giving credit where credit is due. And we'd love to see you all when you can come to Hunt Valley. We have changed the policy in the past week. I took the snapshot of the website a few days ago. We are accepting 2 visitors at a time as long as they wear masks, or 1 family group at a time.